In this video, I'm just gonna go over definite integrals, um, because quite frankly, as long as you watch my other videos and understand indefinite integrals, definite integrals are really easy. Or not really easy, but I don't know, it's just a really big order of operations problem, to be honest. They're not that bad. Um, so when we look at this problem, we have no fraction, nothing we have to really worry about off the start. But the first thing you need to know when solving a definite integral, or a single definite integral, is that you have the function capital F of a, because a being your first limit, minus capital F of b. So all that this means, I'm just going to make it equals c, because you're going to have an answer, but I'm just going to say the answer is c. Now, capital F just means your antiderivative of the function. And then a and b just mean your a limit on top and your b limit on the bottom. So we're working with a single integral for now. I'll make another video on doubles and triples. It really is just a bigger problem, not necessarily harder. But for this specific function, our first step to solving is going to be finding our dx. We need to find our antiderivative of the function in the middle. So we're going to use the power rule. So I've explained the power rule a few times. If we have to find an antiderivative, all we're going to do is take our original number, so let's say 3x squared, we're just going to plus 1, and then we're going to take our 2 plus 1 plus 1, put it on the denominator of the original number, so it's not that bad. So we're going to have 3x, see it's raised to the second, so we can just immediately now, it has to be 3 to the third over 3. Now we have our minus 5x, so we're just going to have minus, well, it's just minus 5x, not negative 5x, you know. So we still have our minus 5. And now we don't immediately know, you know, what exponent is, but just know if the variable's alone, it's just a 1. So plus 1, we have 5x squared, remember, over the 2. That's a really big 2. I'm going to do that one more time. And then we have our plus 2. So the antiderivative of a constant, normally this means add a variable. So we have our 2. So we're just going to do plus. We're just going to have plus 2 and then x. So we found our antiderivative. Now remember, to complete the function, we just need to write our line and with our limits. So we have our 2 and our 1. So not bad so far, right? You know, everything that we already know, nothing too advanced. And now remember what we said before. We found our antiderivative, so these capital F's, we don't have to worry about them anymore. But now we need to plug in our first limit. So a. What's a? It's 2. So the first part of this function, we're going to narrow down to just this right here. Didn't mean to do that. Okay. So now we can just narrow it down to the, oh, well, it did actually take out what I put in, but I don't know, it's kind of useless. We're just going to narrow it down to our f limit a for now. So let's take our function and let's just plug in our a limit, so 2. So now we just have 3 to the third over 3. Now we are going to keep plugging in this limit for everything. So we had minus 5x to the second, so we're just going to plug in our 2 again. And then plus 2x, so plus 2. It's 2. There we go. So that's our f of a. So this part of the function, done. Now we just have to worry about our f to the b. So let's plug in our b limit. Our b limit's 1. So remember our minus as well. And put these in brackets just so I just don't get confused. So remember our minus. So now let's plug in our A or our B limit now. So we have 3. You know, it really is just a really big order of operations problem. You know, really anyone can do something like this. You don't need like an insane amount of calculus knowledge to even know how to do a problem like this. You know, once we start adding in like fractions and stuff, it will get slightly harder, but it's really nothing impossible. You'll notice that indefinite integrals are much harder, because you're working with like a totally new thing. You know, like you do definites after indefinite just so you kind of have it down. So now we have our f of a and our f of b. So we have our function down. So whatever these two things equal, it's our answer. So let's start evaluating this. So let's see. I'm just going to use a calculator just so I don't mess anything up. But 2 to the third, all that is 8. So we're focused on this. So 2 to the third, that's 8. 8 times 3, 24. 24 over 3, that's 8. So that first little thing is going to be 8. Now we have a minus sign, so minus its value. So 2 to the second, that's 4. 4 times 5, that's 20. 20 over 2, that's 10. So we have minus 10. Now we have now we need to do our last part of this problem. So 2 times 2, that's just going to be 4. So plus 4. Now what we're going to do for our second problem, since we have this minus sign, we just have to distribute that to everything that we end up getting. So 1 to the third, that's 1. 1 times 3, that's 3. 3 over 3 is 1. So distribute the negative, we have minus 1. Now our next problem, 1 to the second, that's just a 1. 1 times 5, that's 5. 5 over 2. Remember, we have our minus already, but we're going to distribute the minus again. Now we have plus 5 over 2. So not so bad so far. Now our last part, 2 times 1, that's just 2. So now we have plus 2. Now, once we evaluate this, remember, we have our answer. So now we have it, just an order of operations problem. Really nothing bad. We have no multiplication, no division. We're just doing straight through the line. So 8 minus 10 is negative 2. Negative 2 plus 4, we have 2. So that's for these three, we got 2. Now minus 1. Now we have our plus 2 again. Let's just add our, just our normal numbers. We can leave our fraction for now. So 2 minus 1 is 1 plus 2. That's just going to be 3. Now we have 3. Let's make sure I'm doing this 100% right. I don't want to make any errors, especially since I'm like showing this. Let's see what I did. So we had our minus 1. We had our, oh, I actually see what I did wrong. I knew something had to have been wrong. If we go back to our original problem, we didn't distribute the minus to the plus 2. That is why this equation would not have worked. So I'm glad I caught myself there. Everything else looks to be correct. So, we're good. So I'm going to just continue solving this problem. We have 8 minus 10, that's negative 2, plus 4, that's 2, minus 2, that's, 2 minus 2 is nothing, and then minus 1, so we have the value, minus 1. And now we have minus 1 plus 5 over 2. So what is minus 1? That's really just, you know, minus 2 over 2. And minus 2 over 2 plus 5 over 2, we're going to get positive 3 over 2. And that is our answer. So, you know, just like a really big order of operations problem, really nothing bad, you know. Yeah, 3 over 2, that's going to be our answer to this problem. Let me just erase everything that's going on. I'm going to do one more on this style, and that'll probably be for this video. But I'll definitely mix it up with like fractions, you know, square roots, you know, like I did with the indefinite integrals. You know, I had some videos where I would just do like normal kind of problems like this, and somewhere I would mix it up a little bit and teach like different rules. The one thing that I'm going to write one more time is just our capital F A minus capital F B. So I'll just explain this really quickly. So if we have the antiderivative of f of x, we're adding, you know. So antiderivative of f of x, it's just capital F of x. And say we have just the derivative of f of x. So if we add dx f of x, not antiderivative, just derivative, we're going down. This is just f prime of x. It goes f prime of x, f double prime of x, and then f to the n of x. Hopefully, you know, you guys might know that already, but if you don't, that's just how it is. So let me pull up another integral that I can do on stream. Here's a good one I could do on. Let's do larger limits so we can have 3, 2. And we can do the function 8x to the third plus 3x to the second plus 6x. There we go. And then, you know, don't forget the dx. Okay. So this is our function. What we're gonna do here, you know, just like our last one, we're gonna find the antiderivative to our huge function using the power rule. So we had ax to the third, so we're just gonna do x to the fourth over 4 plus 3 x to the third over 3 plus 6x second over 2. And that's our dx, or that's our antiderivative. So, you know, we have our capital F now. So I could just say equals our capital F, and let me just rewrite our little function problem down here. There we go. So this is our capital F. Now our first limit is 3. So we're going to take this huge function and plug in that 3. What time? We had 6x to the second, so we're just going to do plus r. Or wait, yeah, I didn't mean to put that there. And now, let's put it in brackets. There we go. So this is our capital F of A. Now, this is our minus. So let me just write that down here. That's our minus. That's our capital F of A. So we can see how we're starting to form our equation that we're looking for over here. So let me take our second limit, which is 2, plug the 2 in, so we had 8 fourth. So nice having so much room to do this, because these problems do get really long. Now let me just write this is our capital F of B. So if we put all of this, let me just try to make this as clear as possible. The function that we are looking for is capital F of A minus capital F of B equals C. So if I take this, we find our capital F, find our capital F of A. We have our minus, our capital F of B equals our answer C. So now let's actually evaluate what's going on here. We have 3 to the 4th, that's 81. 81 times 8, that's 648 over 4. 648 over 4 is 162. I'm going to make sure I'm right though, because I don't want to mess that up. So let me just put the phone out. 3 to the 4th is 81. 81 times 8 equals over 4 equals, I was right, okay. So yeah, it is 162. Got that mental math going, you know. I'm going to erase our C for now. So yeah, we're 162 plus, let me see again, 3 to the 3rd, 27. 27 times 3, 81. 81 over 3, it's 27. So I don't have to check that one because that's pretty normal values, but 27. Now we have our 3 to the 2nd, that's 9, that times 6, 54. 54 over 2, that's 27 again. Now remember, we have our minus. 2 to the 4th, 16. 16 times 8. I actually don't know that one. 48. What is it? I don't know. Let's use my calculator. 16 times 8. 128. 128 over 4. 32. So now minus 32. Now we have 2 to the 3rd, it's 8. 8 times 3, 24. 24 over 3, that's 8. Minus 8. Now we have 2 to the 2nd, that's 4. 4 times 6, 24. 24 over 2, It's 12, so minus 12. And then this whole thing will equal our answer of C. So let's combine. So we have 27 plus 27, it's 54. 54 plus 162. I'm going to do it on a calculator because I'm lazy. 162 plus 54, it's 216. So 216, negative 32 minus 8 is negative 40. Negative 40 minus 12 is negative 52. Equals C. So 216, gotta keep typing wrong. 216 minus 52 equals 164. So let's erase this C and write 160. Wow, that's really sloppy. 164. Yeah, that's going to be our answer for our second integral. So you'll notice definite integrals, it really just means they're going to have one definitive answer. Like a number, you know, like in the first problem we have 3 over 2, and the second problem we have 164. You know, indefinite integrals, we're just going to have a string of like just random things like 2 sine or something like that. But in this, we just have a number. So hopefully you guys didn't find this one like too bad.